Hey everyone. So in today's video we will be studying about the solid principles. Solid principles are the fundamental part of programming for scalable and robust applications. So this is the definition of solid principles. This is a set of 5 design principles that promote maintainable, flexible and scalable software developed by Robert C. Martin, also known as Uncle Bob, and widely adopted in object-oriented programming. Alright, so what does this mean is that when you apply these principles inside your code, it means that your code becomes more maintainable so that in future some other developer wants to work, they can do without any kind of problem, and it becomes flexible so that the changes are not too hard to make, and then the scalability means that the worst case scenario can also be handled. So SOLID is an acronym for the 5 principles: the single responsibility principle, open close principle, Liskov substitution principle, interface segregation principle, and the dependency inversion principle. And we will be studying all of these one by one using Typescript, and we will see their definition, and we will see the bad practice and the good practice both, so that you can differentiate between when you can apply these solid principles and when you cannot. Alright, so let's move on to the first principle, which is the single responsibility principle. This states that a class should have one and only one reason to change. It means if we put too many responsibilities inside of the classes, then they become what we call a God object, an object that knows too much or does too much. The real challenge here is finding the balance of responsibilities. So this means that, let's say that you have a user class, and now you have some functionalities in that class, like generating the slug of that username and implementing the login functionality as well. Now what happens is that here, when you are generating the slug to get the username, it was still fine, but when you implemented the login functionality, it is something that is kind of different. Now for login you have to go to the same class, for some small name change you have to go to the same class. This is a bad practice, and in order to prevent this, we use this single responsibility principle. Alright, so let's move on to our IDE and see how this works. Alright, so here we are. Now what I will do is I will create a class user, private username string, private email string, private password string. Alright, and you have constructor, this dot username equals to username, this dot email equals to email, this dot password equals to password, like this. Now what you do is, you might need to generate a slug field. So what you will do is, generate slug. You will implement this method. It will return a string. So return kebab case. I'm using the Lodash library. This dot username, like this. So till now this is fine, but now you are going to implement the login functionality as well. So if you implement it inside this only, login, username, email, password. So I will be using only email and password here for login, and let's say simple console log login. Now here, the single responsibility principle advises us not to do that, as it gives too many responsibilities to the user model. Instead, what we should do is that we should create 2 different services that perform login and sending emails for the user model. Alright, so I will create 2 services, class user account service. I will have a login method, user user password. So I can utilize either username or the password, whatever I want to do, like this. You can pass a DB query or whatever. And the second class email service, send mail. So here I will have email string and the email template, like that. In this way, what you do is you are doing separation of concerns. So the benefits we gain by separating those concerns with the principals are, first is the testing, which is easier to test. I mean, this thing becomes easier to test. Like, let's say you are testing a single feature of sending the email, you are testing the login functionality, you can separately test those and the code becomes well organized. So naturally we have to consider that splitting those methods into their own classes creates multiple objects that may have to be consolidated if needed or used as part of facade design pattern. This is because directly invoking 100 services in a function to perform workflow is not ideal. So you should know when to implement this and when not to. Alright. So this is our implementation of the single responsibility principle, which is the first one of the solid principles using Typescript. So let's move on to our presentation and see the next principle. Second one is the open close principle. What does it say? Software entities must be open for extension but closed for modification. Alright. You can extend an entity but cannot modify it. Let's say there is an entity, a user entity only, let's say. You have name, email and password. So you can extend by adding, like, products, or you can add any other entry in that, like followers and all. But why would you change the field name? Let's say you are changing the mail to user email. It should be closed for modification. You should not do that. This principle states that when you define software entities, you should be able to extend their functionality, but you should not be able to modify the existing entity. Instead, you should add a new mapping or configuration that allows the right strategy to be applied when running it. It means that whenever you are doing some modification in an entity, you should do it through a special kind of configuration. For that, you will need to create a different configuration class, like that. Okay, so let's move on to our IDE to see how this pattern works using Typescript. Here we are. So I will create one type account. It can be admin, it can be employee, it can be manager, and at last it can be an HR as well. Now you create a user class, private name string, private email string, and private password string. Now let's suppose we are adding a new field called as account type. So let's say private account type account equals to admin, like this. Alright. Now what you are doing is you are checking if it is admin. Is admin boolean, return this dot account type triple equals to admin. In the same way, you can have one more thing to check if it is manager. Return this dot account type equals to manager. So till now this looks cool. Okay, there's no problem. This doesn't seem to be any problem here. But what if you had another user type? So Let's say I remove this HR. Here you have admin, you have employee, you have manager. You don't really need to check employee, you just need to check if it is admin, grant certain privileges, if it is manager, grant few less privileges, more than employee, less than admin. But if there is any other account type as well, if I add HR, will you be adding another method here? Instead of above, what you can do is simply add this method, get account type. This will be the account, and then return this dot account type. Alright. Now what you will do is you will create a record const roles record account and string. You know how to use records? I will show you. This is an immutable object actually. So admin, it will have dashboard, employee, it will have nothing, manager, it will have employee list, and HR will have something very dangerous, salaries. They know our salaries. You create a record and then you use it like this: class role service get role user of type user, return string and return roles user dot get account type. Like this. This is how you implement the open closed principle in Typescript, where instead of modifying your entity, what you did is that you added some unchangeable functionalities, unchangeable methods. I mean, you will not be touching those methods, and then you created a record to do all the operations outside, so that you do not modify your entity, you keep it as it is, and you do all your other operations in the other classes. Alright, that is how the open close principle works in Typescript. Now let's move on to the third one, which is the Liskov substitution principle. The Liskov substitution principle: if S is a declared subtype of T, objects of type S should behave as objects of type T are expected to behave. If they are treated as objects of type T. Oh man, what a tough definition. What is that? Don't worry, I will explain you. So what they are saying is that, let's say there is a type T, there is a type S, and from some part of type T you are extracting another type which is a type S. Okay. Now objects of type S means when you are instantiating the type S, means all those classes that are implementing that interface and all the objects of those should always behave the same way as the objects of type T are expected to behave. I am repeating it again. Objects of type S are expected to behave the same way as objects of type T are expected to behave. Alright, and when this will happen? When they are treated as objects of type T. Now, this principle relates to when passing objects or interfaces as parameters. It states that given an object parameter, we should be able to pass subclasses of that object too without changing the behavior of the program. If you are accepting a parameter of type T, you should always be able to accept the parameter of type S as well. Now you understood. Alright. So now we will be moving on to our IDE to implement this pattern. Here I will create one interface. Let's say back, simple back, type T, and push item will be of type T. Let's not define any type. You can define your own. Pop, it returns T or undefined and is empty. Okay. Now I will create a class that adheres to the principle. Class stack T implements bag T, and let's implement this. All right. Let's also have a constructor private items equals to this. In the push, what you will do, this dot items dot push item. But wait, there is one error. If you write like this as well, then also we are facing this error. Sorry, I don't have to write like this here. Argument of type T is not assignable to parameter of type never. So why does this happen? We will be debugging this. What I will do is I will simply add and the error is gone. Alright. Now pop. If this dot items dot length greater than 0, then return the pop, and this returns a removed element, and check if it is empty. So this is quite simple. Triple equals to 0. That's it. So if you see this class, this class adheres to this Liskov substitution principle. Alright. Why? Because first of all, here if you see this is empty. This is empty, saying this will definitely have a condition that the length will be 0. Second thing, with the help of generics, you will be able to pass the types, which are the subclasses as well. And here in the items T, whatever type you pass here will be implemented in the items. So this class adheres to the principle of the Liskov substitution. But now we will create a class that does not adhere to this principle. Alright. I will create a class called as non-empty stack. So what I will do is I will create private tag, let's say any symbol. This will create a new symbol actually. I will have a constructor and if the length is 0, what we will do, dot push tag this dot tag. So the first mistake is here, only you are passing the any type. Anyway, in the push, what you are doing, now in the pop, what you will do, if this dot items dot length triple equals to 1, then now we are returning this item. At last is empty. Also here we need few more implementation. If greater than 1, so you will return this. Alright. Why does this class does not adhere to the principles whereas this class does? I will tell you the reason is that this non-empty stack violates the principle because this bag implementation introduces a side effect as it makes sure that it always contains one last element, thus is empty will always return the false. Okay, because you are always pushing this, just don't push this and it will also adhere to the principle. So that is how the Liskov substitution principle works in Typescript. Now let's move on to see the interface segregation principle. The interface segregation principle. Clients should not be forced to depend upon interfaces they don't use. Okay? So this means that if there are certain interfaces in which a lot of functionality is there, you are taking only one functionality and rest of the functionality, I mean out of 10 you are taking one functionality out and remaining 9 are being used by some other, so those are skipped by this class. I mean such kind of things should be prohibited, I mean should not be entertained, because see what it says that this principle applies to interfaces. It states that when you define interfaces you should make them as thin and as small as possible. If you want more extensibility, you can create new interfaces that derive from existing ones. Alright, so it means that more methods if you include in any interface, it will become more difficult to implement all of them. So with TypeScript, you can definitely mark some methods or properties as optional, but this does not hide the fact that this interface is very that kind of interface will be very generic. Okay, so if we ever want to provide more flexibility for the classes when implementing any kind of interface, we should break it apart into smaller interfaces. Alright, so now let's move on to our IDE to see how does this work. I will create one interface collection. It will take type T. Let's say pushback item T void. It will have pop back void. It will have push front void. It will have push pop front void. Let's say pop is returning the type T only. Anyway, is empty boolean. Insert at item index void and delete at. This will return the item or undefined, the deleted item. Now here is one problem. The problem is you have all of these methods, so it becomes quite difficult to maintain all of these. You create multiple objects of a class that implements these interfaces. Sometimes you may use it, sometimes you may not use this, but anyway, you will have to implement these methods in your class. That does not sound right. In order to prevent this, what you can do, let me tell you. What you will do is, let's say interface collection T, and you will have is empty. That's it, nothing. Another interface array T extends collection T and insert at like this. Also delete at and like this. Apart from that, you can have another interface stack and push front pop front. Let's say T only. And you can have Q as well. Interface Q, push back, pop back, like this. If you do this, then you will be following the interface segregation principle, which is the fourth one of the solid principles, and that is how your code will become more maintainable and more scalable and more flexible. Alright, now we will be moving on to the last principle, which is the dependency inversion principle. The dependency inversion principle, what does it say? A high level module should not depend on a low level module, both should depend on abstraction. It means that, let's think of it in a component hierarchy kind of way. If there is a high level component, the parent component, which is also utilizing its child component, so it should not depend upon the child for its behavior. Instead, if there is a common dependency, then both of those should depend on one abstract implementation. Alright. When you use module in your entities, you should pass them as abstraction instead of directly instantiating them. That is what the dependency inversion principle says, and you will understand more by writing some code. So let's move on to our IDE to write some code. I will define a type player, name, string, email, string. I will create one class player service. Constructor will be empty as of now, and let's say find by email. Yeah, so it will return the player or undefined. So for this we will also create one player repository and then player repository factory. So I will have my players, let's say I have some dummy players, name let's say Robin Uttappa, email test at 2008 dot aussie dot basher. Anyway, now I will have find by email. Return this dot players dot find player like this. I will now create one factory of this. You might know about the factory design pattern, factory method. Player repository factory. So static get instance, return new player repository. And now in the player service, what I will do, const player repository equals to player repository factory dot get instance, and this. Now what's the problem here? Can you identify? This program contains three entities. User service is a top level component, it calls the user repository factory, player service is a top level component that calls the player repository factory to get an instance of the player repository service. The violation principle happens here that we directly import player repository factory inside the function, which makes it hard dependency. If player repository factory class changes, we will have to change the player service class as well. Additionally, we cannot easily test the method in isolation, and we will have to mock the whole player repository factory module to do that. In order to solve this problem, what I will do, I will comment out this code and I will make things less dependent and more testable, and not do that I will pass the instance in the constructor and make it implement an interface instead. So let's say interface player query find by email like this. Let's get some room. So class player service private player query equals to player repository factory dot get instance. So we will create this right away, and before that we will also create player repository. So our player repository, and this will be same only. Now I will have a constructor player query like this equals to Player repository factory dot get instance. I will instantiate directly inside of a constructor. You can see this dot player query equals to player query, and now find by email string player or undefined, return this dot player query dot find by email. That's it. So the problem we solved by doing one thing, that here instead of creating too much of dependency on these, we created one interface that has this method, and that interface is being initialized like this. You're getting it? So that interface has the find by email method that returns the player. From the player query we are getting it, and this player query is equals to, first is this getting the instance. Alright, now this is the all ins and outs of the solid principles. This is how we can implement the dependency inversion principle, and yeah, that's it. We studied all the 5 solid principles and implemented them using Typescript. I hope you like this video. If you have any doubts, please ask them inside the comment section, and please do like the video and consider subscribing for more videos like this. Thank you.